All right, proportions, finally. This lesson is one of the most important concepts that you'll learn in your math career. You're going to continue to use it. It just simplifies so many things, especially word problems. It's just used extensively. So we've already learned what a ratio is. And a ratio, remember, is a comparison of two quantities. Well, a proportion is two ratios equal to each other. So it's just two equal ratios. Well, when you have, so just look down at example 1, 2, and 3 there. Those are all examples of proportions because you can look at them and see that 2 times 3 will give you a 6, and 9 times 3 will give you 27. So using what you know about equivalent fractions, you know that those are equal ratios, which makes it a proportion. Well, when two ratios are equal, when you cross multiply or find their cross products, which is when you're multiplying across the equal sign, that's called finding a cross product. So the cross product here is actually 54 because 2 times 27 and 6 times 9 both are 54. I'll just box that part, but the cross product is 54. If the cross products are not equal, then you know that your two ratios or fractions are not equivalent. So here when you cross multiply, you'll get 33 on both sides, right here. And on this one, 80 times 6 is 480. And 3 times 160 is also 480. One thing you want to be cautious about is, remember, these are two equal fractions. They're not being multiplied. So you can't do things like this. This is a common problem. A student will say, oh, well, I'm going to divide 6 by 2 and 80 by 2. Well, you can't do that because we're not multiplying right here. This equal sign cannot be treated as anything other than an equal sign. So make sure you're not doing anything like that. So the reason we need to know this, you might be thinking, so what? So the cross product is these numbers. How is that going to be helpful? Well, that's helpful when part of the proportion is missing, an unknown value. So, like, look at number 4. I could figure out x on this one without really utilizing a proportion. Just using what I've already learned before. To get from 3 to 6, we multiplied by 2. So to get from 10 to x, I would have to do the same thing. So x must be 20. Well, if you see one like that, you can, of course, still do that very same thing. You don't have to go through any other procedure. But take a look at 5, 6, and 7. These actually are not nearly as simple as number 4 because to get from 4 to 6, you have to multiply times 1.5. Well, it takes more time to multiply 9 times 1.5. And sometimes the numbers are just really, really ugly to multiply, or you just don't know what it is right off. So this process of solving a proportion, all you have to do is cross multiply or find the cross products and then solve the resulting equation, which is what we learned how to do in the 7.3 pre-notes video. So we're going to multiply 4 times x, and then 9 times 6, and it really doesn't matter which side those 4x or 9 times 6 is written on. I prefer just to always put the variable on the left, but you can do it either way. I'm going to wait a minute before I divide, because remember, now we're to the point where we want to get rid of this 4, so we want to divide both sides by 4. I could go ahead and multiply, or I could and I'm just writing it again. Going to divide by 4, divide by 4. So notice that these 4's divide out. So on the left, you've got x. Think about what we were doing back in Unit 4 when we were working with our fractions. 6 over 4 becomes 3 over 2, and you've still got your 9. So if you do it this way, you can go ahead and just multiply, and you've got 27 over 2. If I had multiplied it from this step, if I could have written 4x equals 54, which is perfectly fine. Then divided both sides by 4. 4 still divide out. Now I have to think, oh, okay, I need to simplify that, which you can just divide both by 2, and you will get the very same answer. But you'll see that this method right here of maybe not always multiplying is sometimes really helpful, saves a little scratch work, but either way, you'll get the same result. So let's move on and take a look at this next one. So 5 times y equals 3 times 8. Well, 5 doesn't go into 3 or 8, so I'm going to just go ahead and multiply 3 times 8. Then I'll divide both sides by 5. And, you don't have to mark out the 5s like that. That's up to you. I could leave my answer as 24/5, which is really what I would do. Or you could convert it to a mixed number, and it would be 4 4/5. Or you might want to put 4.8, as we were talking about conversions in Unit 6. Any of those are fine. Later, when you have a word problem, one will make more sense than another, most likely. If you want to try this last one on your own for a minute, feel free to stop the video at any time and try it, but do watch the rest of the video. Don't skip ahead thinking you kind of have it all. Who knows? I might give some brilliant nugget of information that you'll miss if you don't listen to the video. All right, if you're still with me here, I'm going to just write 5 times 18. I'm just showing right now that you don't have to have the variable on the left. Fine, doesn't matter which side it's on. So I want to eliminate the 24. I want to get rid of it because it's with the z. So to undo it, I'm going to divide by 24. Now I'm going to write a separate step just so that your notes will be clearer. And I suggest you do it that way too, at least in your notes right here. So now we're going to do the part where we're going to divide both sides by this number, 24. But what I do to one side, remember, I have to do to the other. So I'm purposely putting the 24 under the 18. And I didn't want to multiply 5 times 18 because maybe I don't even know what that is, and I have to do some scratch work. So now I can simplify 18 over 24 because 6 goes into both of those. So I can save myself a little bit of work. So 6 goes into 18 3, 6 goes into 24 4 times. So now I just have 15/4. And I would leave it just like that. But again, if you want to convert, not a problem. All right, let's keep moving. So here's where I'm really addressing how proportions are actually going to change your math life. The power is in their problem solving. You might recall previously having a lot of trouble knowing if you should multiply or divide in particular situations, because it really is confusing at times. Well, proportions are going to get rid of all of that. They're going to make it a lot simpler. So part of your homework is some word problems, but the bulk of it is problems like the ones we just did. We're going to kind of continue to work on these word problems, so I don't want any of you thinking after one assignment you're supposed to master all problem solving here. But when it says use a proportion, and I want you to use proportions when I put that on your assignment, don't fall back on other problem solving techniques, because remember, we're trying to move forward, we're trying to learn something new, not just trying to repeat things that we already know, unless they're really efficient. Proportions are super efficient, so let's use them. So when you read something like this, Jeff made 2 out of every 5 baskets. Well, when you see that 2 out of every 5, the first thought you should start to have now is, hey, that's a ratio, 2 per 5. Okay, even a rate, if you will, from what we've learned. So 2 baskets out of every 5 that he shot during basketball practice. So then it says if he took 40 shots, how many baskets did he make? Well, let's label a little bit. Up here at the top, these were the ones that he made, and these were the ones, well, I'll put shot. I was going to say attempted, but he shot 5, he made 2. So when you're trying to get the other side of the proportion, you'd say, well, if he made 2 out of 5, and if he shot 40, and I have the number he shot on the bottom, I have to put over here, I need the number that he shot on the bottom. And that means I'm looking for how many he made. So I've got made over shot and made over shot. Now, this is one that's pretty easy to solve, even without using a proportion. You can look at it right there and see, oh, well, 5 times 8 is 40, right? To get here, you multiply by 8. So that means to get here, you'd have to multiply by 8. It's perfectly fine to utilize that, but we're going to practice solving a proportion. And so we need the practice, so I'm going to do it that way. But I already know my answer is going to be 16, because I see it right here. But if I use a proportion, get there, and I'm not going to tell you not to use those. It's just I'm not going to give you problems where it's going to be so easy all of the time. All right? Sorry, I've made a mess up here. So now if we cross multiply, we'll have 5x, 5 times x, 40 times 2, and I can either write 40 times 2, or I could go ahead and just write 80. I prefer it this way because when I divide both sides by 5, 40 goes into 5 8 times, so I'd have 8 times 2, and that is 16. Now this is a word problem, so you need a unit of measurement. So it says, how many baskets did he make? Oh, well, he made 16 baskets. You don't have to write a full sentence, but if you do, that's fine as well. Then you look back, make sure it makes sense. Yes, it makes sense. Because if you had if you had 16 over 40 and you divided both of them by 8, you would get 2/5. So it makes perfect sense. So let's try another one. Tyra Tyra gets 2 quarters for every newspaper, 3 newspapers she delivers. So right when I see that, I think, okay, I'm going to put quarters over newspapers. And it doesn't matter. I could have put newspaper over quarter. I'm just doing it the way I'm reading it. So 2 quarters for every 3 newspapers. So if she delivers 105 newspapers, so newspapers goes on the bottom, and on top I'll have how many quarters. Then this part right here, I'm just kind of labeling to help me know that these are all the newspapers and these are all the quarters right there. So I'll step over to the right to cross multiply here. So we get 3 times x, it's right there, 3 times x, and right here we want 2 times 105. Now I already know that 2 times 105 is 210, and in this particular case, that is actually a little bit easier to work with. Because when I divide both sides by 3 3 goes evenly into 21, 7, and then I just tack on my 0. So in that case, it actually worked out better for me to multiply 2 times 105 before I divided by 3. How many quarters will she get? So this is quarters. There's our answer. All right, I believe we've just got this one last one. So if you're wanting to try it on your own, you know, you're always welcome to stop and do that and then come back to check. Now, this particular problem came from your book on page 305. So you really need to stop for a minute, open up your book, and look at that. But there's a table, and it tells you some things, and it's a little confusing. I want you to look at the table, but if you look at it, you'll see a bar that says that 1 US dollar is equal to 0.72 euros. So not exactly a whole euro, a little less than that. If the question is, if that's true, then what is the value of 9.2 euros in US dollars? And I'm sure this is not the current exchange rate, but it was at the time that this book was written. So I could start with this right here is giving me a rate or a ratio. It's if I think of it as dollars on top and euros on the bottom, again, I could flip it, it doesn't matter. So that would be $1 is to 72 euros as how many dollars is to 9.72 euros. And then we solve. So we've got some decimals here. That makes it a little bit more complicated. The kids' life is full of decimals. Too bad, but it's not all nice, pretty whole numbers. And then 1 times 9.72. So I'm going to get rid of the 0.72. It's being multiplied, so I'm unmultiplying. So I'm dividing by 0.72. Those divide out. So now I've got to remember a little bit about dividing with decimals, but we've already been reviewing in our last unit, last section even. So I need the divisor always to be whole. So if I've shifted over 2, I have to do the same on top. So I'll have 972 over 72. And I could just start trying to simplify doing some things there. But then all of a sudden I realized, oh yeah, this has got to be money because I'm looking for how many US dollars. So I could still simplify and then divide, but honestly, in this case, I think it's just as easy to jump in and do the long division. So I'm just going to go ahead and do the long division after I've already converted and moved my decimal things. Because that goes once, that's 72. Subtract, bring down. So 72 into 252, it's going to go about like 3 times. Let's see, 3 times 2 is 6, 21. Now, when you get right here, you're going to subtract and get a remainder here of 36, but you don't want to put 13 and 36 over 72. I mean, maybe you do. It'll be easy to convert in this case, but it's money, so you could put a decimal and keep going. 72 goes into 360 evenly 5 times. So that actually comes out to be 360, and I get 0 remainder. So in terms of money, this is $13.50, which is how I want to answer that question. And there you go. So you're going to learn a lot more about things to do with proportions, but hopefully you've got a taste of how they make word problems actually easier. So have fun with it, take your time, and just know that you're going to continue to get more practice. See you next time.